This is a series of tutorials on building a straightforward online game using Microsoft Signal R and React. Welcome to the fourth video in the series. In our previous 3 videos, we discussed creating a user database in SQL Server and developing a web API to connect to it. We also covered creating UI with React using TypeScript, as well as implementing user login and registration functionality in a React app. If you're just joining us, I highly recommend watching the first 3 videos of this series to catch up. In this video, I'll cover how to create JWT tokens and refresh tokens. Let's jump into the coding. In our web API application, we require the inclusion of attributes for handling JWT tokens and refresh tokens. Therefore, I'll navigate to the user models file to add the necessary properties to each user for managing these tokens. First, I'll add the property for the token. Then, I'll include the property for the refresh token. Finally, I'll integrate the property for the refresh token expiry time into the user model file. Once we've edited the user properties to include the necessary attributes for token management, the next step is to update the SQL database schema accordingly. This ensures that the database structure aligns with the changes made to the user model file. Open the terminal and execute this command to add the new migration to the database. This command will generate a new migration file named addToken, containing the necessary SQL scripts to update the database schema based on the changes made to the user model file. To update the database with the changes made to the user model file, execute this command in the terminal. This command will apply the pending migrations to the database. Let me show you what the SQL database looks like now. You can see there are new columns for the token, refresh token, and expiry time. Let's create the JWT token when user logging is successful. After a successful login, I'll add a new createJWT method that will accept user properties and return the JWT token. Let's create a new private method to generate the JWT token. This line defines a private method named createJWT that accepts a user object as a parameter and returns a string representing the JWT token. Here, we initialize a new instance of JWT security token handler, which is responsible for handling JWT tokens. We define a secret key as a byte array. This key will be used to sign the JWT token for verification. Next, we create a new claims identity object to represent the user's identity. We add a single claim to the identity, which is the user's username from the user object. Here, we create signing credentials using the secret key and the hash-based message authentication code 256 algorithm. These credentials will be used to sign the JWT token. Now create a security token descriptor object to configure the JWT token. We set the subject of the token to the user's identity, specify an expiration time, 1 day from the current time, and provide the signing credentials. Now we create the JWT token using the createToken method of the JWT security token handler, passing in the token descriptor we configured earlier. Finally, we write the token as a string using the writeToken method of the JWT security token handler and return it from the method. This completes the process of generating a JWT token for the user. Next, we'll add authentication services to the application and specify JWT bearer as the default authentication scheme for both authentication and challenge. Before changing the default authentication method, we need to install the JWT bearer package in our project. Please open the terminal and add this package using this command. This command will install the JWT bearer package, which is required for configuring JWT bearer authentication in our ASP.NET Core application. Here, we add authentication services to the application and specify JWT bearer as the default authentication scheme for both authentication and challenge. Next, add configures JWT bearer authentication options. Require HTTPS metadata. Specifies whether HTTPS is required for metadata. Set to false for development purposes. Save token. Indicates whether to save the token received in the authentication ticket. Token validation parameters. Specifies the parameters for validating the JWT token. Validate issue signing key. Indicates whether to validate the issuer signing key. Issue signing key. Specifies the key used to sign the JWT token. Let's define the same symmetric security key that we used when creating the JWT token. This ensures consistency and compatibility between token creation and validation. Validate audience. Indicates whether to validate the audience. Validate issuer. Indicates whether to validate the issuer. Validate lifetime. Indicates whether to validate the token's lifetime. Clock skew. Specifies the amount of time to allow for clock skew when validating the token's lifetime. Here, it's set to 0. Meaning no tolerance for clock skew. After setting the user's token using create JWT, we assign the generated token to a variable named new access token. Then, we save the changes to the database using dbcontext.savechangesasync. Finally, we return an HTTP 200 OK response, along with the new access token wrapped in an object. Let's save the changes and run the Web API application to verify the JWT token creation. Before login, let me show you what is the current state of the database. Let's proceed with the login process. Please provide the username and password that we registered before. Great. It appears that the new access token has been successfully created. This indicates that the JWT token creation process is functioning as expected. Let's check the database to see if the token has been saved for this user. JWT token for the user, Madhawa, has been successfully saved in the database. This confirms that the token creation and database update processes are working correctly. Let's proceed with logging into another user. It's excellent to see that the user, Heshen, now also has a JWT token saved in the database. Let's navigate to our React app and implement the functionality to save the JWT token to the browser's local database. When the server responds to the login request with the newly created JWT token, we'll implement the logic to save this token to the browser's local storage. If the result contains the access token, we'll simply log the access token to verify that the process is working correctly. Let's save the file and check the result to ensure that the access token logging is functioning as expected. It's good to see that the access token for the user, Madhwa, has been successfully logged into the console. This confirms that the process of retrieving and logging the access token is working as intended. Let's proceed with saving this access token to the browser's local storage. We'll use local storage.setItem to save the access token with the item name, JWT token, and the item value as the result containing the token. Let's remove the console log and instead set an alert with a message indicating a successful login. After a successful login, we'll use the React navigation hook to navigate to the home page. Save the file and let's check the update. Let's open the local storage of the browser. I will log in as Madhwa again. You can see that the login process is successful, as indicated by the alert message, and that the JWT token has been saved to the browser's local storage. This confirms that the navigation and local storage functionality are working as intended. After successful registration, we'll navigate the user to the login page to complete the authentication process. The JWT token creation functionality has been successfully implemented. Let's proceed with implementing the refresh token functionality. Refresh tokens are essential for maintaining user sessions and enhancing the security of your application. We'll work on setting up the refresh token mechanism next. Let's navigate to the Web API application. We'll create a new folder named DTOs inside the Models folder, and within that folder, we'll create a new file named tokendto.cs to handle token-related data transfer objects. Update the namespace. defines a public class named TokenDTO. Defines a public property named access token of type string. This property will hold the access token generated during authentication. The get, set syntax indicates that the property has both a getter and a setter. Similarly, defines a public property named refresh token type of string. This property will hold the refresh token used for refreshing the access token. Let's navigate to the user controller file. After a successful login, we'll return an OK response with the new token DTO. We'll set the access token equal to the new access token and the refresh token equal to the new refresh token. Next, we'll proceed with creating this new refresh token. Defines a private method named createRefreshToken that returns a string representing a new refresh token. Generates a byte array of 64 random bytes using the randomNumberGenerator.getBytes method. These bytes will be used to generate the refresh token. Here, The byte array generated above is converted to a base 64 encoded string, representing the refresh token. Checks if there is any existing user in the database with the same refresh token. If such a user exists, it indicates a collision, and we'll regenerate a new refresh token to avoid duplicates. If a user with the same refresh token exists in the database, the method recursively calls itself, createRefreshToken, to generate a new refresh token until a unique one is obtained. Finally, the method returns the generated refresh token, ensuring its uniqueness in the database. Let's add this method and save the returned value to a new variable named newRefreshToken. User.refreshToken equal to newRefreshToken. Let's add an expiration time to refresh token. We'll set the refresh token expiry time property of the user object to the current date and time plus 5 days. User.refreshToken expiry time equal to datatime.now.addDays. I will give 5 days. Let's save all the files and run the application again to ensure that the changes are applied correctly. Let's move to the React app. After a successful login, we'll set the local storage to include the refresh token as well. Let's save the file and proceed to check the updates in the application. Let's log in again. You can see now that the login process was successful and that the new refresh token has been saved to the local storage as well. This indicates that the integration between the React app and the backend API is working correctly. Let's quickly check the SQL database to ensure that the refresh token and its expiry time have been correctly updated for the logged-in user. Now you can see that the refresh token and its expiry time for the user, Madhwa, have been correctly updated in the SQL database. This confirms that the back-end functionality for refresh tokens is working as intended. Today, we learned how to create a new JWT token and how to generate a refresh token for logged-in users. We also learned how to save these tokens to the local storage of the browser. In the next video, I will discuss real-time token refreshing with the backend and refresh token validation, generating a new JWT token with each refresh. We'll continue our journey as we develop an online tic-tac-toe game using React, TypeScript, and Signal-R. Join me as we delve into the fascinating world of real-time web applications. Please stay tuned throughout this series to learn a lot. If you enjoy my content, please subscribe to the channel, like the video, and hit the notification bell.